Yeah guys, just driving to go get my tattoo done. Got some tattoo time today. Just thinking later on I got a date with some woman. She's a little bit older than me. I think she's 26. So 4 years older than me, but she sounds pretty cool. So but I was thinking later on when we go for this meal, I was thinking of bringing up the infinite monkey cage hypothesis or theory. Whether that's going to be a little bit too much, but I just think it's kind of that kind of mind blown experience. If she doesn't know about it, then it'll be pretty cool, and if you don't, I'll kind of go into it. But basically, obviously, we've kind of established that space is constantly expanding. We have the inflation theory by Alan Guth. Okay, basically, space is constantly expanding due to inflation, constantly ever getting greater and greater with the speed of the previous expansion. And we've kind of established that, well, space is infinite and time. There is no brick wall that you are going to put in space, because behind that brick wall, behind that barrier, there's going to be space. So we've kind of established that, you know, somewhat conceptually, there is no way that space stops. There's no brick wall, because, well, use your brain. What's behind the brick wall? So in an infinite world, the hypothesis is that, and it's kind of just a funny joke, kind of, you know, icebreaker kind of physics discussion, but it's quite deep because it gets you thinking about, wow, what does infinite really mean? But in an infinite world, they say, which I believe because I'm a probability person, logical probability person, that in an infinite world, a monkey sat in a room would at some point in time, bear in mind infinite, okay, we have an infinite amount of time, so in some amount of time, a monkey sat in a room with a typewriter would type out the whole works of Shakespeare. Now that sounds crazy, but I now have the logical background and like the mathematical probability perspective of, doesn't sound as crazy as it seems really, because we're talking in infinite time, so every possibility would have to play out. Okay, I hope that doesn't sound too crazy, but basically they say, these scientists who study this subject, this area of physics and cosmology, that within our universe or within our galaxies we have black holes, okay, and within these black holes no light comes out, okay, they are completely dark. As soon as you go in, you don't come out. But these scientists, what they are discovering, what they are saying is that within these black holes are like pathways, are like portals to other galaxies, okay. So in an infinite world, scientists are now saying that, so we've got the multiverse, so there are multiple universes, and so that in some place in time right now, because this is an infinite world or an infinite universe, there is another person like me now driving, but I'm not going to get my tattoo today, I'm going to a job interview. Or in another universe, I'm not meeting a girl later at Prezzo, we are going to some other restaurant. Because it's in an infinite world, every possibility and every probability would have to play out. So it's just, I thought that would be a nice cool icebreaker. Hey, do you know about the infinite monkey cage? Now, the infinite monkey cage is so cool just because it gets you thinking what infinite really means, or infinity, what it really means. An infinite just life source, a constantly vast amount of time, space, and energy. And it's really just getting thinking of how much your life, you know, how much it really all means, and what means more to you than, like, you know, what these little things that you consider significant, how insignificant they really are when you start, you know, looking at all this sort of stuff. But yeah, the infinite monkey cage is a very cool hypothesis, and let me know if you think that would be a nice little icebreaker. I mean, we could start going into quantum mechanics and talking about quantum entangled particles, how you have these two particles which have gone through a two-split experiment, and by going through the particles, they take a two-way diversion, and they are actually entangled, but they can be in two different locations. They can be in two different universes, but still be entangled. Crazy abstract, I know. And basically, once you measure one of the particles by maybe shining a laser on it to measure its spin, you automatically change the properties of the other electron. Either the electrons concave come together and meet as one. So in effect, that you've had one electron in one universe and one electron in another universe, and they have come together. Okay, where you get that's where you get the quantum leap from. You can have a quantum leap, the all of a sudden movement, or you can instantaneously change the spin of the other electron. If one electron is up, spin, or down, or up, spin, then the other electron, you already know that it's up or down. If one's up, you know the other is down, because they're either up or down once you measure them. So that'd be pretty cool. I hope she's into cosmology and physics. Or maybe not, or maybe I'm just going to confuse the hell out of her. Or I could say the next galaxy to us is Andromeda. Okay, we are the Milky Way. The next galaxy to us, Andromeda. If you were on Andromeda now with a telescope, looking down at Earth, trying to see me in this car, what you would see is the time of Earth, and what would be around? Dinosaurs. That's how far back you would see. You would see dinosaurs roaming the Earth, because that's how long the speed of light would be. For example, when the sun, if the sun were to explode, it's 7 light years away, or 7 light minutes away. So it would take 7 minutes for the impact to actually hit Earth. So just as if you were on Mars and you shot a message down to Earth, we wouldn't get it instantaneously. It travels at the speed of light. Hence why the quantum entanglement is so interesting, because quantum entanglement kind of gives out the impact, or the kind of evidence that speed can travel faster than light, because you are having somewhat of, you could have quantum bits, quantum entangled bits or particles that have travelled, and scientists have actually experimented this, and it's actually worked, where they've had quantum entangled particles like 50 miles away, and they've actually impacted one of them with a laser, and the other one has shot across, somewhat travelling faster than the speed of light, of which Einstein said that could never happen. He called it spooky action at a distance, this quantum entanglement. He wasn't satisfied with quantum physics or quantum entanglement, because it didn't meet his laws of relativity. So, interesting stuff. But we shall see. I got like 40 minutes until I got my tattoo. It's quite a nice day, bit of fog around me. It's quite nice. I have a cold, which is strange because I haven't had a cold for quite a while. But then again, it's not strange because it's a probability game. I'm going to get a cold at some point, even though I'm healthy. So anyway, guys, thank you for watching. That was a short 9-minute clip, so we shall see. I might do a bit of an update video how it went. Did I blow her mind? We shall see.